Network traffic tools have been around in one shape or another for many years. While they may have been adequate in visualizing traffic data, they lack intelligence about the network. The operator must piece together dashboards from multiple products to triage an incident. Octera solves this problem by ingesting telemetry from all parts of the network. With that data, it is able to build a multi-layer model of the network and use automatic machine learning-based anomaly detection to alert operators of problematic conditions. In this video, we are going to highlight several examples of how Octera brings intelligence to traffic operations. In our first example, the operator receives a complaint from the application team. They want to quickly determine if there are issues in the network. Starting in the topology view, we adjust the time to the last 30 minutes. Next, the operator chooses what data they want to see. In most tools, the operator will look at the interface metrics and start going through the network to try and find congestion. But with Octera, we simply configure it to display anomalies. After doing that, we can see that there is one on the network during this time. Next, the operator also wants to know if there have been any network events. After updating that setting, we now see some events related to BGP adjacencies. Looking a little closer at the anomaly, we can see that it's for interface discards. To see how Octera can map application flows across the network, watch the video, Visibility Across Applications in the Network. In this video, we are next going to confirm if the discards are still happening. To do that, we'll use the Octera Trends view. The first thing the operator does is adjust the time to the last 30 minutes with a 1-second data interval. In the graphs below, we are displaying metrics related to traffic, discards, and errors. On the pinboard, the devices and interfaces are ranked in order and are currently sorted by top interface out discards. Scrolling down, we see that we do have discards that align with the anomaly. They appear to be related to a single interface. You can adjust the filter so only its data is shown. If desired, the operator can even change the time to the last 5 minutes to monitor the interface in real time. Using the combination of topology anomalies and trends, the operator was quickly able to see an issue on the network and know if it's still happening. But what if the issue was a while ago and the operator needed to go back in time to investigate the network? With Octera, they can do that by adjusting the filter for a specific time. In this example, we're looking at a specific event on April 22nd. After adjusting the time, the interface traffic out statistics update for the whole topology. In this scenario, the operator only wants to focus on traffic-related anomalies, so they will add a new filter for traffic anomalies. After that, they will add anomalies to the show section so that they are displayed on the topology. Here we can see that during that time period, 2 devices in the network had traffic-related anomalies. The operator can select the anomaly to see more details. The anomaly will contain details of the event and the interface. Scrolling down, we can also see the time series data. In this specific example, we have a significant anomaly on the out octets, along with an anomaly on in octets. These all correspond with an anomaly for a major jump in discards. Note that the time period is between 7 and 8 a.m. The operator then goes back to the topology diagram and looks at the metrics for that interface. Notice there is a major drop in traffic leaving the interface and a spike in discards. And then at about 7:45, things appear to go back to normal. This is a real traffic anomaly from a production deployment. Octera does anomaly detection on individual interfaces, but can do this on groups of interfaces as well. In this example, Octera is doing ML on aggregated traffic for all the interfaces connected to a colo. The traffic increases by over 100 gigabits per second, and an anomaly is clearly seen when looking at the time series. In fact, Octera has produced several anomalies since the event started, as seen when selecting past anomalies. Next, we're going to highlight the power of analyzing data in Octera using heat maps. The operator wants to make sure that their fabric interfaces are load balancing correctly. They have set up a view that displays all the interfaces attached to devices that have been identified as being part of the fabric role. In this example, they're looking at traffic data from the last 6 hours. In addition to the color scale, the actual metric values can be overlaid to see more details. In this example, we're looking at interface output traffic, but it can be leveraged for other types of metrics like fan speed or CPU. And Arctera can combine any combinations of dimensions in the heat map. To summarize, we showed examples of how Arctera was used to find and research a traffic event in real time and one that occurred in the past. We used a combination of the network topology view and trends view to analyze the network, find anomalies, and see the status in real time. Arctera also has a dashboard, which allows you to combine the various views into a single page. In this traffic dashboard, we are combining several views together to make it easier for the operator. Arctera is intelligent traffic visibility, powered by AI and machine learning, enabling operators to better understand and manage their networks. To see how to use Arctera to isolate the root cause of traffic issues, watch the video Proactive Network Brownout to solve application performance issues. Thank you for watching.